Skill 40, Graphing Absolute Value Functions. The goals of this skill are going to be to graph an absolute value function. A function that contains absolute value brackets is known as an absolute value function. Our absolute value function is y equals a times the absolute value of x minus h plus k. Our general graph of absolute value is going to be a V shape. And that V shape is going to have a vertex right there at the origin, and it's going to go up 1 over 1 to make the V there, and then it's going to reflect over that x-axis or y-axis to get the other side. So that V shape is our standard parent function of the absolute value. Okay, so the A is then the slope. So whatever the A is, that's going to be the slope of how far we count or whatever. Then, if A is positive, then our V is going to be a V shape. It's going to open up like this one does here. If our A is negative, then it's going to open down. So our V shape will actually be like that. So it'll flip over and look like that. If the absolute value of A, so if our A right here is bigger than 1, so if it's a whole number, any number bigger than 1, like 2 or 4 or 5, any number that is bigger than 1, then the graph is going to become narrow, so it'll be tall and skinny. So that would be something kind of like this. It's going to become narrower, taller, and skinnier. So that would be if A is greater than 1. But if A is less than 1, absolute value of A is less than 1, then we are talking about some sort of graph that is wider. The A is going to be a fraction, so the graph would become wider than the original. Okay, but we can still find what that is by graphing the slope, which is rise over run. Okay, and then we have the vertex. So the vertex, this is a very important point. That's the point that happens at HK. So the H right here and the K right here. That is going to be our vertex. So those are the important points that we have to be able to identify. So that's the vertex, that's where we start, that's the point right there. The H is going to move the graph left and right. So we're going to move left and right based on whatever the H is. So if it says it's minus H, we're going to go right. And if it says plus H, we're going to go left. And the K is going to move up, down. So if it's plus K, we're going to go up. And if it's minus K, we're going to go down. And that's what we're going to have to be able to do here. Take our V shape and move it around. For these first examples, we are just going to state how the absolute value has moved, or how the V-shaped, the original V-shaped, has moved. So it might be helpful to draw our original, which is right there. That's where we start. We always start with that parent function. How did we move it? Well, it looks to me like it goes 1, 2, 3 to the right, and 1, 2 down. So that is going to say, we literally say 3 right, and 2 down. But this also looks like it's taller and skinnier than it was. If I start at my vertex here, then I see I have to go up 1, 2, and then over 1. So that means my slope, or I guess my M, or my A, because that's what it is with absolute value. My a is up to and over 1. So I would say that it's kind of a vertical stretch or a horizontal compression. You can look at it any way. But for these points, if you just want to tell me that the a is 2, that is okay with me. All right, and then for this next one, you can go back and sketch out my original, starting at the origin, going up 1 over 1, and that yellow there is my original function. So I want to figure out, how did I move to get to that new function? All right, well, it looks to me like I went over 1, 2, 3 to the left, and 1, 2, 3 up. And that would be enough for this. And it appears as though the width has not changed. It's not narrow, it's not fat and short and wide. So the a doesn't change. A is going to be equal to 1. So there you go. That's how you would describe what happened. So you're changing the v somehow and describing how it changed. For this next example, we are just going to draw the translation. So we have our original parent function. The y equals absolute value of x is this red one. And I want to move up 2. So up 1, 2. And then my vertex is there. And the slope of my absolute value isn't going to change. So that's what it's going to look like. For this next example, it's inside the absolute value, x plus 5. So I'm going left or right because it's in there with the x, and because it says plus 5, I am going to go to the left 5. 1, 2, 3, 4, 5. So that is going to be the vertex of my graph. And again, I am not stretching it at all, so it's just going to look the same, just shift it over. This next one is, 2 things are happening to it. So first, we do have this plus 2 on the outside. So plus 2 outside the absolute value is going to tell me up 2 for my vertex. But then I have this minus 1 inside that absolute value, and that's going to tell me to go right 1. So I'm going to take my vertex of my parent function, move right 1, and up 2. So that right there will be my new vertex, and then I can actually draw my graph. Here's one more example of that. Multiple things happening. We have a minus 4 outside the absolute value, so that says we're going to go down 4. And then I have this plus 2 right here inside that absolute value, so plus 2 means left 2 spaces. So I'm going to count left 1, 2, and down 1, 2, 3, 4. So then my new point is going to be right there, and then I can draw my graph. It's a V shape just like that. So that would be your final answer. That concludes our notes on graphing absolute value functions. You should be able to work through the homework problems now, 1 through 10, and be prepared for your quiz.